Our warm-up is a good review from the unit that we just finished. If the cosine of theta is -4/5 and theta is between pi over 2 and pi, so let's think to ourselves, pi over 2 and pi is quadrant 2, and in quadrant 2, remember that we have cosine is negative, sine is positive, and then tangent is negative. So if the cosine is -4/5, and cosine would be negative here, find the cosine of pi minus theta. Pi minus theta is the supplementary theorem, and that means they're in side-by-side quadrants. So for this one, I'm in quadrant 2, and I'm going to move to quadrant 1, where cosine is +4/5. You don't have to write the positive sign. I'm just writing it there so that we know that we figured out the correct sign. All right, for part B, cosine of pi plus theta. Again, I'm always starting in quadrant 2. Pi plus theta means that we're going halfway around the circle, so diagonally. So I'm going to be here. And my cosine in this quadrant is also positive. And it's going to remain, of course, 4/5. Right, for letter C, again, I start in quadrant 2. Opposite of theta means that I go up and down, so I'm going to go down to here. And cosine on this side of the unit circle is negative, so this would be a -4/5. Right, now for letter D, I'm in quadrant 2, and I'm staying in quadrant 2, but I'm looking at the sign. Sign in quadrant 2 I know is positive. And now I have to find the number part. So this is where I'm going to use my Pythagorean identity theorem. Cosine squared plus sine squared equals 1. So I have 4/5 squared. And it is -4/5, but when I square it, it's going to become positive. Plus sine squared equals 1, so I get 16/25. Plus sine squared equals 25/25. And when I subtract the 16/25 from each side, I get, I hope I've been talking loud enough. I just realized that I was facing away from the microphone, so hopefully you've been able to hear me. Equals 9/25. Take the square root. I don't need plus or minus because I know I only need the positive. So I get sine of theta equals square root of 9 is 3, square root of 25 is 5. So I get 3/5. Right. For the next one, it says, I'm in quadrant 2, and it says pi over 2 minus theta. This is the complements theorem, which means that I'm going to look at the sign of the complementary angle. So if 3/5 is the sign, so in every ordered pair, remember I have the ordered pair then is 4/5, 3/5, and for the complementary one, it's going to switch, and it would be 3/5 for the cosine and 4/5 for the sine, so it's going to change. So if the sine of theta is 3/5, the sine of the complement is going to be 4/5, and of course it's going to remain positive. Because remember we said with complements, it just switches x and y. For instance, a 30-degree angle is the ordered pair square root of 3 over 2, 1/2. A 60-degree angle is the, here I'll write this down so you can see it. 30 degrees, we have the ordered pair square root of 3 over 2, 1/2. And at 60 degrees, we have the ordered pair 1/2 square root of 3 over 2. These are complementary angles. They add up to 90. And their cosine and sine switch. All right, and then lastly, we're asked to find the tangent of theta. We're in quadrant 2. We stay in quadrant 2. Tangent in quadrant 2 is negative, and I need to find the tangent by taking sine over cosine equals the tangent. So the sine is 3/5. The cosine is 4/5. So that's going to be 3/5 times 5/4. And I get then, after the 5's cancel, I get 3/4. Moving right along, let's go ahead and find the exact value for each of these. So I am going to try and do this without a calculator and without even looking at a unit circle. I know that on my unit circle I have the ordered pair 1, 0, and at pi over 2 I have the ordered pair 0, 1. At pi I have the ordered pair -1, 0, and at 3 pi over 2 I have the ordered pair 0, -1. And this is for both 0 and 2 pi over here on this right side. And then all I really need is this first quadrant at 30, which is going to be pi over 6. So pi over 6, this is going to be pi over 4, and this is going to be pi over 3. I have square root of 3 over 2, 1/2. I have square root of 2 over 2, and square root of 2 over 2, and I have 1/2 square root of 3 over 2. So I'm going to remember that and use that. All right, so as long as I know quadrant 1, I can figure out all of the other quadrants because I know that these ordered pairs are just repeated in the other quadrants. What I do is I think of this first ordered pair is my pi over 6 family, and I'm going to have a pi over 6 coordinate here, and one here, and one here. This would be my 5 pi over 6, this would be my 7 pi over 6, and this would be my 11 pi over 6, etc. Let's start with letter A. Cosine of pi. Pi is right here. Cosine is the x-coordinate, and my x-coordinate is -1. Sine of pi over 4. Pi over 4 is right here. Sine is the y-coordinate, square root of 2 over 2. Tangent of pi over 2. Pi over 2 is right up here. Tangent is sine over cosine, so that would be 1 divided by 0, so that's undefined because you can't divide by 0. Sine of 11 pi over 6. I know that this is my pi over 6 family, and it's the one in the fourth quadrant. So in the fourth quadrant, the x-coordinate would still be positive, and the y-coordinate would be negative. So right here, this would be square root of 3 over 2, -1/2, and sine is the y-coordinate, so it's -1/2. Cosine of 4 pi over 3. I know that this right here is pi over 3. The one next to it over in this quadrant would be the other 2 pi over 3. 2/3 and 1/3 would add up to 1, so this would be my 2 pi over 3. Down here would be my 4 pi over 3. And everything, well, sine and cosine in this quadrant are both negative, so I know it's negative. And cosine is the x-coordinate, so -1/2. Tangent of 5 pi over 4. All right, this is my pi over 4 family. This would be my 3 pi over 4. This would be my 5 pi over 4. The tangent in this quadrant is a negative divided by a negative, which is a positive. And it's sine over cosine. And square root of 2 over 2 divided by square root of 2 over 2 is simply 1.